In last two videos, I briefly explained multiplexing. It is the type of bandwidth utilization. In this video, I am going to explain completely spreading type of bandwidth utilization. Now, we will explain spread spectrum. Where we will use this spread spectrum means we are used in wireless application, means you are going to use in wireless application. In wireless application, all stations use air or vacuum as a media for communication. Means we know that what is meant by wireless. Wireless means there is no presence of wire for the communication. Okay. Next, what is the goal of this spread spectrum? Station must be able to share the air media without interception by an attacker. Means this should not be affected by any of the attacker. That is the goal of this spread spectrum. For that, what is the solution? The spread spectrum technique add redundancy. That is nothing but they spread the original spectrum need for each station. Means they are going to spread the original spectrum need for each station. Next one, if the required bandwidth for each station is B. Okay. Next, spread spectrum expanded to bandwidth spectrum such that this bandwidth of, here you can see that here BSS means bandwidth of spread spectrum is greater than bandwidth of the station. Always this spectrum bandwidth is always greater than bandwidth of the station. What this expanded bandwidth will do means the expanded bandwidth always the source to place its message in private envelope for more secure transmission. Means this expanded bandwidth will place the source message in secure form for secure transmission. Means it will place the source message in envelope for secure transmission. That is the concept of this spread spectrum. Observe this figure. You can see that this is the source bandwidth spreading process. For spreading process, we are applying spreading code. What is meant by spreading code? Series of number that look random but are actually a pattern. Means this spreading code is nothing but series of number that look random but are actually a pattern. Pattern nothing but zeros and ones. Okay, we are going to applying the spreading code. So this band will be expanded. Here you can see that here bandwidth is small, here the bandwidth is bigger. So always this spread spectrum bandwidth is always greater than bandwidth of the source. Okay. Next, there are two types of spread spectrum. First one is frequency hopping spread spectrum, direct sequence spread spectrum. There are two types of spread spectrum. We'll discuss one by one. Next, here what is meant by frequency hopping spread spectrum, FHSS. Here you can see that this technique use m different frequency that are modulated by the source signal. Means in this figure you can observe that this frequency synchronizer will produce the carrier frequency. This frequency will be modulated by original signal. That is only they are telling that m different frequency means this produce the n different frequency, and this m frequency carrier will be modulated by original signals. How it will happen means, see here, one moment the signal modulate one frequency means one moment it will modulate only one carrier frequency. Means one time it will do one frequency carrier modulation by signal. At second moment it will take another frequency carrier and it will modulate it by the original signal. Okay, what is the bandwidth? The bandwidth occupied by the source is given by, means the bandwidth of the FHSS is greater than bandwidth of the original signal. Okay, observe the figure here. This is FHSS. Okay, here pseudo random code generator is there, frequency table is there, frequency synthesizer is there, and modulator is there. And for modulator, the original signal is the input, spread signal is an output. How this will work, we will going to see here. See here, this pseudo random code generator create a k bit for every hopping period of th. Means this pseudo random code create a k bit it is going to generate. Okay, what this frequency table will do? Frequency table use pattern to find the frequency to be used for the hopping period. Means this frequency table use the k bit pattern. Okay, for what it will use the k bit pattern? Means to find the frequency to be used for this hopping free period. Means to send to this frequency synthesizer, it will refer this k bit pattern and it will collect the frequency and it will send to ear. Okay, after sending ear, it will transfer to modulator. Here the carrier frequency will be modulated by original signal and it will send as spread signal. Okay, for example I will show here. You can observe that here this is pseudo random code generator will produce the k bit pattern. Okay, these are k bit patterns. Okay, this is frequency table. It is here means this table contains the k bit. This here it is containing the frequencies. Okay, you can see that pseudo random code generator will create a different 3-bit pattern. Okay, you can see that 1 2 3 4 5 6 7 8 different type of 3-bit pattern. There are 8. In 8 there are 3-bit pattern, 1 2 3 1 2 3 like this. There are 3-bit pattern. This frequency table refer the k-bit pattern. Okay, for first one 101. Okay, here where is 101? 101 is there. What is the 101 frequency? That is nothing but 700 k hertz. This will send to frequency synthesizer. Okay, this will be sent to frequency synthesizer for modulator, and this original signal modulate this 700 k hertz frequency, and it will send as spread signal. That is the explanation of this frequency hopping spectrum. Means you have to write this diagram and you have to explain it. Next, what is the bandwidth sharing of FHSS? Okay, here you can see the explanation. Number of hopping frequency is m. We can multiplex m signals into one channel. Means there are 10 channels is there. Means we can multiplex, means we can combine to form one channel. That is the meaning of that statement. And how we can do that? How we can multiplex m channel into one channel? Means using same bandwidth of spreading spectrum. Okay, next, how this is possible? How we can multiplex m channel into one channel using same bandwidth of spreading spectrum? Means it is possible because a station use just one frequency in each hopping period, and other m minus 1 station use other m minus 1 frequency. In other words, you can say that m different station can use same spread spectrum bandwidth if a multiple FSKs used. Means m different station can be used same bandwidth of spreading spectrum. That is the meaning of this. Okay, next type of spreading spectrum is direct sequence spread spectrum. This technique expands the bandwidth of original signal. Why? What the use of this direct sequence spread spectrum? Means this technique expands the bandwidth of original signal. Means it is original signal bandwidth after modulator, after direct sequence spread spectrum. It will expand the bandwidth of the original signal. Okay, here you can see that each data bit is replaced with n bit using spread spectrum. Means data bit is replaced with n bit using spreading spectrum. Here you can see here, this is original signal 101. Using spread spectrum, it is replaced by n bit. Okay, n bit means here we use 11 bit. N bit is one bit is replaced by n bits. Here n is equal to 11 means here original signals 101. Each data bit is replaced by n bit using spreading code. Means this one bit is replaced by 11 bit. You can see that 0 0 0 0 1 1 1 0 1 1 0 1 means count here 1 2 3 4 5 6 7 8 9 10 11. There are 11 bits is replaced by 1 bit. Okay, this is polar NRZ line coding technique. Here also 0 is placed by 11 bit. Here 1 bit is replaced by 11 bits. This is the meaning of this. Okay, each data bit means bit means here 101 is the data bit. It is replaced with n bit using spread code, nothing but here n is equal to 11. This 1 bit is replaced by n bit by using spread code. That is the explanation of this. Okay, next one is each bit is assigned a code of n bit called chip. We will call it as chip. Chip rate is n times of the data rate. What is chip rate? Is nothing but n times of the data rate. Means n types the chip rate is n times greater than the data rate. That is the explanation of this statement. Here you can see that it is the DSSS. You can see that original signal chip generator means it will produce the sequence of bits here. Here the modulator will change the carrier frequency and it will produce the spread signal. Means here the bandwidth will be low, here the bandwidth will be expanded. This is the explanation. You can see that this technique expand the bandwidth of original signal. The original signal bandwidth will be increased after the modulator by using the DSSS. Okay, you can see that this is original signal. After spreading code, the spread signal is increase the bandwidth. You can see the increased bandwidth here. Okay. Next concept is bandwidth sharing in the DSSS. There is a question: can we share the bandwidth in DSSS? The answer is no and yes. We can share the bandwidth also and we cannot share the bandwidth also. There is a two situation where bandwidth can be shared, where bandwidth cannot be shared in DSSS. When we cannot share the bandwidth means if we use spreading code that spread signal that cannot be combined and separated, we cannot share the bandwidth. In this case, we cannot share the bandwidth. Next one, when we can share the bandwidth. If we use special spreading code that spread signal that can be combined and separated, we can share the bandwidth. When we use special spreading code, we can spread the signal that can be combined and separated. There we can share the bandwidth. When we are using normal spreading code, that spread signal that cannot be combined and separated. Here we cannot share the bandwidth. Okay, here this is the end of the spectrum concept. Okay, next video we will move on to the next chapter in chapter 2 in module 3. Okay, thank you.